Okay, let me say something about proofs, in particular the proofs in the Modular Arithmetic chapter. Now, it is easy to get the idea that a mathematical proof is some kind of magic incantation you can have to get just right in order to make it work, but that's not what proofs are about. Proof is nothing more than a clear explanation of your thought process in coming to the conclusion. Now, proof is like a chain. Every link must be connected to the one before and one after. Sometimes there are multiple links that connect to a single link, but it's the same principle. So everything you say, you need to connect it to what you've asserted or proven previously and what you want to conclude from that statement. When writing up a proof, ask yourself the following questions. I think this is important. You really should ask yourself, am I really making clear what each step means? Have I explained what each variable means? And if I showed these proofs to someone else in class, could he or she follow the argument? One thing you can do is write down your proof, come back to it a day later, and see if you understand what you're talking about. If you don't understand what you're talking about, that's an idea that maybe you're not writing a clear proof. Okay? Again, I want to emphasize that the format is not what's primarily important. You're writing an argument, and you can write your argument in various forms. What's important is clarity. When I read these proofs that you write, I ask myself these questions. Do I understand what each step means? Have you explained what each variable means? And can I follow what they're thinking? If I can see what you're thinking from what you've written, then I will say that proof is okay. That's what a proof is about. It's just conveying your ideas to somebody else. Okay, let's see how this applies in an actual example. This was on the homework, exercise 347. Use part B of proposition 3.4.4. Show that if L is an integer and A is the remainder of L mod n, then the remainder of L squared mod n is A circle plus A. All right, so part B of this proposition says, given L and M are two integers, if A is mod Ln and B is mod Mn, then looking down at part B gives me mod of L times M mod n is equal to A circle plus B. All right. So I'll start with part A. We'll do part B in a minute. And basically ask yourself, what's the idea here? What idea are you using? Well, in this proof, all you're doing really is just replacing M with L. If you replace M with L, then B becomes what? Well, B is mod Mn. If I replace M with L, I get B is mod Ln, which is equal to A. All right. So let's just start to write that down, and then we'll put it together into a proof. That's an argument that will clearly express your idea. So the idea is you're going to, in proposition 3.4.4 B, replace M with L. Okay, that's the basic idea. All right. So let's flesh it out a little bit. Okay. Now here, this is scratch work. You wouldn't actually put this in your final answer, but this is scratch work. Okay. If M is replaced with L, then B is replaced with what? Well, it's replaced with mod Ln, which is equal to A. Okay. All right. So then the statement gives, let's see, mod L times L, I'll just write this way, and is equal to A. I'll just write C plus A. All right. So what you're doing is a replacement. Okay. So, all right. So let's put this. So this is my link of ideas. All right. I'm starting with the proposition part B, and then my link is I'm simply doing replacement. You can do replacement. That's the same thing as substitution. Right. So that's linked to my next chain. My next link of the chain, and then here I'm drawing that out a little bit. If M is replaced with L, then the B in this part is replaced with mod Ln, because that's the definition of B, and then that's equal to A. And the statement gives mod L times L n equals A circle plus A. Now, this is basically the proof, right? You can just write it that way. So here's the proof. Okay, this is what you would actually write on the paper and just say almost the same thing. Let me just write this and just redo the words a little bit. Okay, I can say in proposition 3.4.4b replace m with L, and then I can say then. All right, I can say then b is replaced, or b is replaced is okay. That's fine. I think actually this is good enough. I mean, if you read this, can't you see exactly what I'm doing? And that's the point. Okay. Now, what I've been doing another way is give a statement and then give a reason. I've done that in class sometimes when I'm doing a proof. Then I could rewrite the same thing as I could rewrite the same thing in that same format. If I do it that way, I really can get to the conclusion in just one step. I can just write down mod L times L n is equal to A C dot. Oh, I said C plus, sorry, that should be C dot, right? That's a circle dot, not a C plus. I'm only doing it this way because it's easier, faster to type this way. So mod LLN is equal to AC dot A, and then the reason is in proposition 3.4.4, replace M with L, and B equals mod Mn with mod Ln. Okay, those are consistent replacements, right? Because if I'm replacing M with L, that's what happens here. And that's equal to A, right? Okay, so that's my reason. And then here I can just say mod L squared n is equal to AC dot A. And then that's just the definition of L squared. Okay. All right, so you can do something like that. And there are other alternatives also. In a minute, we'll look at some of the arguments that you submitted and see, and I'll critique some of those. I think that may be good, valuable for you to see. All right, now let's do the same approach on part B. Using part A, prove a similar relation involving L cubed. Now, what you kind of want to say is, well, just do the same thing again. But that's not enough. You have to explain what you're really doing. Okay, what does it mean by doing the same thing again? You can't just say by part B substitute because you don't have three factors here. You know, this is L times L times L, but you don't have three factors. You're going to have to do something, and you're going to have to do something twice, right? You're going to have to apply something like this twice, because if you associate this is going to be L times L and then times L, right? So you using the associative law, you kind of have to break it down. All right, so let me just clarify this a little bit before I move on. This is the actual proof, and then this is alternative proof. Right, so I hope it's clear what I'm doing. I'm trying to make clear what every statement in my proof is talking about. Okay, so let's look at part B. So for part B, the basic idea, all right, and this is for part A. Okay, just trying to make clear everything what's going out here. So the basic idea, I'm going to use associative law and apply, basically going to apply proposition 3.4.4 twice. Okay, so that's the basic idea. Now that's really not enough detail. Okay, so but I can kind of follow this sort of pattern here. So what replacements am I going to make? So this is going to be with different replacements. Okay, so I'll flesh this out. So in the first replacement, what am I going to replace here? Well, here I have L times L times L, right? So here I only have L times M. So I'm going to have to make this M be L times L, okay? So I'll replace M with L times L, okay? Then what happens? Then B is replaced by, is going to be mod L times L N. But we already know that by part A, that's the same thing as A circle is equal to A C dot A by part A. Okay. All right. So that's the first thing, and that will get me. So that gets me. All right. Now see. I said I need to use 3.4.4 twice. Actually, I've used 3.4.4 once, and then I've also used part A once. But part A used 3.4.4. So that gets me what? Does that get me what I want? Well, that gets me, let's see what does get me. I have mod. So remember, I'm taking L dot, and then I'm replacing M with L dot L. And that's going to be equal to A C dot, and then this is going to be mod L dot L N, and that's the same thing as A C dot, then A C dot A. Okay. All right, now some people ask a good question, what about associative law? Can I just write this as AC dot AC dot A? You could actually show this proof the other way. Instead of substituting L dot L, you could substitute L dot L dot L. You could do that, but this is good enough for us. Okay, so let's go ahead and write the proof. So let's do the actual proof. Okay, I'm going to copy this. Okay, let's see. So let's copy this and see how I can write it as an argument that makes sense. Okay. All right, so let's see. All right, so I'm using associative law. So let's say that. So by associative law, I can say L cubed is equal to L dot L. All right, that's the associative law. Then I apply proposition 3.4.4 twice, but let me do it one at a time because I have to do it link by link in the chain. Okay, by proposition 3.4.4 with M replaced by L dot L. Okay, that's good. All right, then B is replaced by mod L dot Ln equals AC dot A. That's still that's fine. So here, let me put this on a single line so it makes sense. Okay, and that's by so let me just do this in a single step. Okay, because I combined two steps. B is replaced by mod L dot Ln by part A mod of L dot Ln is equal to AC dot A. Okay. So I just say making these replacements gives. All right. So I'm taking mod L dot. Like I said, I'm replacing M by L dot L, and then here I'm replacing. Here I'm just writing these different steps in my argument and writing it in equation format. Okay. All right. So here, I think that if you think about this, I'm actually justifying every step, and it should be an argument that you could reproduce and follow. Now, you can also do it the other way. Let's do the alternative proof, where you show the statement and then the reasons. Okay. Alternative proof would be, let's see, I'm going to say first, well, let's see, I'm going to say, I can actually write this one down. All right, that's my statement. And then I can say, this is proposition 3.4.4b with m replaced by L dot L, and b replaced by mod L dot L n. Okay, and then the next step I can say is let's see. So I can also say let's just do it this way. I can say this part here, mod L dot Ln is equal to AC dot A, and that's by proposition, that's by exercise A. Okay. And then finally what I'm doing is I'm simply substituting AC dot A into here. So that becomes mod L dot oh, I'm sorry, I forgot the first step. I forgot the first step. The first step would be about L cubed, mod L cubed n is equal to mod L dot L n, and that's associative law. Okay, and then here I forgot the n, sorry. Okay, and this is probably too small for you to see. Let me make it a little bit bigger. Hopefully you can see that. All right, that should be big enough, I hope. All right, so mod L, okay, so I have this, and then this is not right. This should be like this. So I'm going to go back, and when I finish, I'm going to go back and check and make sure I wrote it correctly. Okay. All right, so let's see. So we have associative law. So let's look at this. We have associative law, which says I can break up the L cubed into two parts like this. And then here, this one should have a dot here. So the dot represents times, right? So I have mod L dot Ln. So I replace the m with L dot L, right? And then that means that the b is replaced by mod L dot Ln, right? So here I made it very clear what the replacements are that I'm doing. So I think this step is okay. And then this one here, mod L dot Ln equals AC dot A. So that's from exercise A. That's direct, right? That's just quoting exercise A. Well, I'm being a little bit loose here. I'm just saying L dot Ln is AC dot A because L dot L is L squared, right? So then finally, I can put these two together. I'm basically substituting this one into this one. That's exactly what I'm doing. So I can say substituting second equation into first equation, right? So that's what I'm doing. So mod L dot L n is equal to A C dot. Now all I'm doing is I'm replacing this mod L dot L n with AC dot A. AC dot, and then it's A C dot A. Okay, and this is just replacing second equation into first equation. Okay, right. All right. So there's a lot of words, but if you step back and look at it, you really can see, I hope, that there's some step-by-step reasoning here, and it's in such a way that someone could duplicate the same argument. All right, so let me critique a couple of papers just to give you an idea of what I'm looking at here. So here's one paper. First of all, you should notice that this is almost completely illegible. This is what I see when I see the. It's very difficult to read. So please, when you scan, make sure that you should scan it directly. Probably it's better to do a scanner than a cell phone if you can't get it straight on. You should take your picture straight down. Just if you should turn off your flash because that will make glare, but you can make sure that you're in a room with a lot of light, and then you should get a clear picture. Make sure that it's legible before you send it. All right, so this is very difficult to read. So I can critique part B down here. Part B, it says so if you remember the questions I asked here, the questions that I asked about proofs are, one of the questions I asked is, have I explained what each variable means? And here there's no explanation of what m and n are, what m and b are. I mean, b is mod mn. There's no explanation what m is. I don't know what m is. So I really can't put all the links of the chain together. All right, now this one here, let's take a look at this. Does this meet the criterion? Well, where are the reasons? I don't see any reasons here. That's one problem. Another problem is here I'm using A dot A. That's not correct. It's A circle dot A. So two problems here that may take points off. All right, now this one here was correct. I just want to point out that the first two steps are really not necessary. You've just restated the proposition. But otherwise, I see all the steps here, all the variables are defined, there's a reason for everything, and so that one got full credit. All right, now let's look at this one. This one is kind of all over the map. Where does the proof begin? Does the proof begin up here? Does it prove over here? Does it begin over here? I kind of guess the proof begins here, but there's no indication that tells me that it begins there. So that's one difficulty. Another difficulty is, let's follow this argument. So the first statement in the proof says, if L is in Z and A equals mod Ln, then mod L squared n equals A circle dot A. Where's the reason? In fact, this is what you want to prove. How can you include what you want to prove as the first statement in your proof? There's nothing here to tell me that this is what you want to prove. Here it's just asserted as if this was something that you're using in the proof. Then here you say let M equal L and B equal A. So what does that mean? Where? What? Why? I mean, you are making those substitutions, but where are you making them? You're making them in this proposition part B. It's just not clear. If you wrote this, like I said, if you wrote this down, came back a day later and tried to figure out what you were doing, it would be impossible to figure out. You're just not giving enough reasons, not showing me what you're doing. Okay. All right, now this one here was marked correct, but there really is a problem with this. The point of proving theorems is that you use them and save work. Now what this person did was went back and reproved the proposition 3.4.4. And that's not what you want to do. Proofs are like building blocks. You want to build, you don't want to keep going back to the ground floor and building up again. If you built the ground floor, build the second floor on top of it. So, as I said, this time it got credit, but later on I'm not going to give credit for proofs like this. You need to use the things that you've already proven. All right, so let me critique this one. All right, now here the person restated the hint. Now, see, this is a hint; it's not a proof. I'm referring to proposition 3.4.4. But when you write out the proof, you shouldn't just say this. You should say let M equal L and B equal A in proposition 3.4.4. Okay, this is fine. This is fine. And then it says, so we have mod L dot Mn by 3.4.4. Now this is not 3.4.4. This is just an expression. 3.4.4 is that this is equal to this expression here. So these two lines should be combined together. You should say, so we have mod L dot Mn equal this quantity by 3.4.4b. And then you can do the substitution. And then that argument is clear. So this has the pieces, but they're not put together very well. All right, now this one here, we start with A equal mod Ln. That's fine. Then here you say mod L squared n equal A circle dot B. Now, where did this come from? I don't know where this came from. It just says algebra. I kind of was pulled out of thin air. Then instead of using the proposition, you're going back to the definition of L and B. So I just kind of lose the argument here at this point because things are not clear. You never define B. It's just not clear. I don't know how this came. All right, so that's all the critique I'm going to do. Hopefully that gives you some idea, and you can do better next time. I'm going to critique one more theorem, one more proof, and then again, I hope that will be helpful for you.